Okay, so I'm going to go over numbers 3, 9, 12, and 15 on this worksheet. Okay, and this is all for our substitution. So let's look at number 3. We already have an isolated variable y, which is equivalent in value to the 5. So when I was giving that example in class, like, oh, Miss Hong is coughing, she's really sick, she's got a cloud of germs around her, but there's this 5, let's say it's a substitute, Miss Hastings, she's substituting in for Miss Hong. Miss Hong is supposed to be right here, but the 5 is going to substitute instead. So what is the 4 doing with that y? It's multiplying, so you're going to do 4 times 5. So we rewrite this equation, negative 3x plus 4, instead of 4y, it's 4 times 5 equals 8. And then this becomes negative 3x plus 20 equals 8. And then we box and circle, subtract 20 from both sides, get negative 3x equals negative, well, if you had 8 minus 20, it's negative 12. Divide each side by negative 3. Now remember, you'll want to use that online calculator as practice, okay, but it's up to you. So we have the y already, which is nice. That doesn't always happen. In fact, it happens very, very rarely. And then this one is 4. So our answer is 4 comma 5. It's one solution. Not that you have to write that, but please write it. Please remember it, okay? Number 9. This time we have, again, the y being isolated, which is equal in value to the negative 3x. Find that y here, and that arrow goes right in. So 4x minus, we're rewriting that second equation, minus 2 times negative 3x equals negative 20. So then these get multiplied. That's a negative 2 times a negative 3. That's a positive 6. And then don't forget the x, equals negative 20. We've got like terms over here, they combine, and that's 10x equals negative 20. And then, whoops, that goes together. Alright, and then divide by 10, so x equals negative 2. And then, so I'm going to put the negative 2 here, find the y. Well, the y is already isolated in that top equation, so we're going to put the x in that bottom, with that equation. So y equals negative 3 times negative 2, and so y equals positive 6, which goes here. And that is the answer to, that's the solution to the system. And since there is an x and y, then that's where they will, that's where the solution is. It's a one solution. Okay, now let's go to number 12 on the back. So we've got an isolated variable here, which is equivalent in value to there. So here's that isolated variable. That 3x minus 4 should go in there. So you get 4x plus 3 times all of that. So there's a 3 here, but then there's a 3x minus 4 in there. So you put the 3x minus 4 here, and then you finish it out. So before we do anything here, you got to distribute. You can't even box and circle until you distribute. So we get 4x plus 9x. And then 3 times negative 4 is minus 12 equals 1. Box, circle, circle. Combine those. 13x minus 12 equals 1. Add 12, 13x equals 13. Divide. So x equals 1. That gives me one of my values. And then I'm going to put it in the top one because the y is already isolated. So I'm going to put y equals 3 times 1 minus 4. Nothing's happening over here, so I rewrite it. 3 times 1 is 3. Minus 4, I'm going to rewrite it again. 3 minus 4, be careful. 4 minus 3 is different than 3 minus 4, so you got to go in order. 3 minus 4 is negative 1. And then that goes there. And that's my solution. Go to number 15. Isolated variable is equal to this expression. Whereas that variable, that y minus 4 is going to go in there. So this gets rewritten as negative 2 times y minus 4 plus 3y equals 6. Distribute. Negative 2y plus 8 plus 3y equals 6. Boxing and circling, these are on the same side. Negative 2y plus 3y is 1y plus 8 equals 6. Subtract 8 from both sides if you want to box and circle. And then we get y equals negative 2. going to plug that back in, or substitute that back into the top because that top already has the x isolated. I'm going to put the negative 2 here because we found the y first this time. So to find the x equals negative 2 minus 4. So x is equal to negative 6 when we combine that. So the solution is negative 6, negative 2. And our answers are down here. You can use that to check. 6 and 8 were good problems to do, which we did in class today, because you never know when you run into no solution infinite solutions.